Hey guys, welcome back. Here we go with another one, guys. This one's Notes 35, continuing the log life. I guess you can call this logs 2 as well. So here we go. Example 1, it says log 5, find log 5 of 17, check your answer. If you know your change of base deal, then you can always do that. But if you don't, so what they want is they want a numeric value, or they want us to figure out what this is. So if I write log base 5 of 17 equals x, which is what I'm really trying to find, I'm trying to solve for x, we can rewrite this as an exponential, guys. 5 to the power x equals 17. And then when we get to here, well, that 17 is not like a perfect from 5. Like 5 squared is 25, 5 cubed is 125, stuff like that. So what we want to do is we want to solve for x here. And I want to bring that down, and I'm going to utilize the properties of logarithms. So I'm going to write ln. Whatever you do to one side, you got to do to the other. So ln. So now I'm going to bring the x down. So you have x ln of 5 equals ln of 17. And if you want to use parentheses, you may. So now to get the x by itself, there is a product, x times ln of 5. To get the x by itself, you just divide. So x equals ln of 17 divided by ln of 5. And if you want to know what that is, I guess I should write approximate because it's a decimal that goes on forever. I'm going to take my little calculator here. I'm going to write ln 17 divided by ln, oh, that's not divide, divided by ln 5. And then I push enter, and you get that number, 1.760. So let me write 1.760. And if I were, it says to check my answer. Yes, today's calculators, you could just type in log base 5 of 17. So maybe this type of question is obsolete. But if you get if you get this in an entry-level exam, if you're taking an entry-level exam for a university like A&M or something like that, they might ask you this question without a calculator, guys. So math, log base, I'm going to put 5 here and 17. And I'm going to push enter. And there it is, 1.760. Now, if you knew something called a change of base property, you could have easily have used this formula right here. So notice if I have log base 5, what was it again? I already forgot. Short-term memory. Log base 5 of 17, you could have just said, oh, okay, that just means ln of 17 over ln of 5. And you could have been done immediately. This is called your change of base property because you can change to any base, as you can see here. And these two really are the same. It's just that this one does 1 over log base b of a times log base b of x, which is really just the numerator there, see? So they're the same. All right, guys, let's continue. This is actually very handy, guys, especially when you're taking math entrance exams with no calculator. Solve the exponential equation f to the 3x equals 983 algebraically using logarithms. Okay, just like before, so 7 to the 3x equals 983. I want to bring this 3x down. So what I'm going to do is you put an ln on the left, you put an ln on the right, because whatever you do to one side, you do to the, you do to the other. Bring the 3x down, so 3x ln of 7 equals ln of 983. And then what you want to do is you want to get rid of that 3 and ln 7. So, because it is all a product, 3 times x times ln 7. So I'm going to divide by 3 ln 7. 3 ln 7. So then we have x equals ln 983 divided by 3 ln 7. If you're taking an exam with no calculator, I would leave it like that. And there it is. That's it, guys. I don't know why my laptop does that. It just zooms in when I'm just with one finger here. All right, the next one. It says solve the equation. I have the base, and I'm adding, and it equals 3. And it says to check my solution. So it looks like I might have more than one. So let's see. So I have a plus here. So that means I can just write one single log. And I can write x minus 1, x minus 3 equals 3. And then let's turn this into an exponential. So 2 to the power third equals, and then x minus 1, x minus 3. And then let's go ahead and expand this guy. So 2 to the power third, that's 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8. So I'm going to write 8 equals, and then when I FOIL this, that's x squared, and then I'm going to have minus 3x minus x, so that's going to be minus 4x. and then I'm going to have a positive 3. There it is. Now, the way to solve these guys is just like you've always been doing them, guys, when you were in Algebra 1, is just to get this to equal 0. So we can, factor out. So something times something equals 0. It's easy to solve. So I'm going to move that 8 to the right. So minus 8 minus 8. So then I have an expression, 0 equals x squared minus 4x minus, let's see, negative 8 plus 3. That's a negative 5. So then you have this. And then that is easy to factor out. Let's see, two numbers that when you multiply give you negative 5, but add up to a negative 4. So that's going to be a negative 5 and a positive 1. See, negative 5 times a positive 1 is a negative 5, and negative 5 plus 1 is a negative 4. So from here, you get two answers. So let's see, the only way I will get this to equal 0 is if x equals 5, and if x equals negative 1. Now, both of them do not work. If you come back up here, remember that your argument, the inside expression, must be positive. So let's see, the 5 works. 5 minus 1 is 4, and then 5 minus 3 is 2. That's going to work, but the negative 1 is not going to work because it's going to be negative. Now, let's just see if it works. So let's see, log base 2, 5 minus, well, I guess I'll write it. 5 minus 1 plus log base 2, and then 5 minus 3 equals 3. So we already know this is 4. We know this expression is 2. I'm going to take my calculator. I'm going to see if I really do get that 3 there. So I'm going to write math log base 2, and that's a 4 there, plus math, come on buddy, log base 2, and then obviously the base 2 to the 2 is just a 1, right? And I push enter, and there it is. You get a 3. The other one would not work if I plug in a negative 1. Like, I'm just going to do one expression here. Math log base. I'm just going to try the base 2, and if I typed in the negative 1 in there, negative 1 minus 1 is negative 2. And look, you get an error, guys. Imaginary answer. It actually does mean something, but not in the context of the course that we have, because of the domain of logs. The domain of logs is all real numbers for x, and then the range is all real numbers. So for x, it's just, did I say all real numbers for x? No, all positive numbers for x. So sorry, guys, because all log functions look like this, all of them. Because they're just the inverse of exponentials. All right, let's continue. So this one's an ln. Natural log and log are like brother and sister, guys. So they're pretty much the same thing. So again, I'm going to go ahead and go ln, one giant statement. I'm going to write x plus 3, close, open, x plus 5, close, equals 0. And now I want to solve for this. And the way to solve for it is, remember that there's a property that says log base e of x equals ln of x. So you can either, you don't have to, you don't have to go this route. If you know that natural log and e are inverses of each other, you can just raise e to all this, and then e to the 0, that's just going to be 1. But if you don't know that, you got to use this property. So log base e of x plus 3, x plus 5 equals 0. All I did was use this property, guys, of what natural log is. So now look, e to the 0 equals that expression. If I turn this into an exponential, you would have gotten the same answer anyways if you would have gone the other way. E to the 0 equals x plus 3, x plus 5. All right, e to the 0, anything raised to the 0 is 1. And when I FOIL this out, you're going to get x squared plus, let's see, 5, 6, 7, 8 plus 15. Move the 1 over, so 0 equals x squared plus 8x, and I subtracted 1, so that's going to be a 14. And then you got to think, let's see if it is. I don't know, we might have to use quadratic formula. Two numbers that when we multiply give us 14, but when we divide, when we add up to an 8. So are there two numbers that when we multiply give us 14 but add up to an 8? No. So we're gonna have to use the quadratic formula. A is 1. I don't know why it does that sometimes. A is 1. B is 8. C is 14. So here we go, guys. My x values in this case is going to be negative 8 plus minus square root of 8 squared minus 4 times 1 times 14 all over 2 times 1. In case you're wondering what I just did, I used the quadratic formula, guys. Negative b plus minus the square root of b squared minus 4ac all over 2a. So I'm going to take my calculator and hopefully let me go here and then can I move it? Yeah, I can move it. Come on, buddy. All right. So I'm going to go alpha, get the little fraction there. Negative 8 plus square root, and I'm just going to go 8 squared minus 4 times 14 all over 2. I'm going to push enter, and I get one value is a negative 2.586. I'm going to store this to A, guys. Store alpha A. Negative 2.586 stored to A. Come on, buddy. Okay. Next, I'm just going to scroll up. And instead of a plus, I'm going to put minus. So I'm going to put minus right here. Enter. And I get negative 5.414. You already know what I'm going to do. I always like to go down the alphabet. I'm going to store it to B. So I'm going to go store alpha B. All right. So now that I have these answers, I'm going to see which one will work. Let's see. I can already tell you which one's not going to work. This one's not going to work because I will have a negative argument inside. Negative 5 plus 5 is a negative. Negative 5.4 plus 3 is a negative. So it's not going to work. But the A one will. Look, and we'll test them both, guys. All right. So let me get it right here. Come on, buddy, move. Okay, so here we go. I have it stored in A. So I'm going to write ln alpha A. I'll open up 2 parentheses. Delete. Plus 3. Close. Plus ln alpha A. My A is my x, right? Alpha A. Alpha A plus 5. And if I push enter, OMG, that one works. So there it is. There's my answer, guys. The B one will not work, guys. So look, check it out. ln and then alpha B plus 3 and then plus ln alpha B plus 5. See? None will answer. All right, let's continue. So my only answer is this one right here. And of course, this is actually the approximated value. The real answer is what you have in the calculator there. All right, let's do this one here. At first glance, it says solve the equation and check your solutions. At first glance, it looks like, okay, how am I going to do that? But it looks very similar to a quadratic, guys. So what I mean by quadratic, when you were in Algebra 2, you had x squared. Well, I guess let me write it the way your Algebra 2 teacher wrote it. Ax squared plus bx plus c equals 0, just like we did a little while ago. And then we said that the solutions for this, if it's not factorable, you said that the solutions were x equals negative b plus minus the square root of b squared minus 4ac all over 2a. There's actually a nice little proof for that, guys, but we'll wait for later on. But anyways, so there it is. And actually that works for anything that looks in the quadratic form, guys. So if I have something that looks like this, if I have, let's see, if I have A with a triangle there squared plus B triangle plus C equals 0, then I can get my solution for that triangle. My triangle is going to be the same thing, negative B plus minus the square root of b squared minus 4ac all over 2a. So I don't have to have, it doesn't have to be an x, it can be anything. So if you notice, well, that says e to the power 2x, that says e to the power x. This looks like a quadratic, guys. I can rewrite this as e to the power x squared minus 3 e to the x plus 2 equals 0. And now we're good. Now we can say, oh, okay, that looks just like this. So now what I'm solving for is e to the x, as you can see. Or maybe you can factor it out. Maybe this is factorable. So I'm going to put, this is similar to x squared minus 3x plus 2 equals 0. Is this factorable? Well, yeah, that one is definitely factorable. X minus 2, x minus 1 equals 0. Negative times a negative is a positive. Negative 2 minus 1 is negative 3. So if this is similar to that, if either is similar, then that means I can write my new expression as e to the x minus 2, e to the x minus 1 equals 0. So now I can just solve, I can say e to the x equals 2, and that definitely is possible. And e to, why did it do it over there? E to the x equals 1. So this one's simple. E to the x equals 1, the only one that will work is x equals 0. So let's figure this one out. So let's see, I'm going to bring that x down, so it's best to use ln, because ln of e is 1. So I'm going to write x ln e, well that's just 1, equals ln 2. Ln e cancels out, so x is ln 2. And so both of these, I think both of them will work, but let's see. Let's figure it out. Let's come back over here. And the 0 one will definitely work. E to the 0 is 1, 3, e to the 0 is another. Well, e to the 0 is 1, so you get 1 minus 3, which is negative 2, plus 2 is 0. So the 0 one definitely works. And the ln 2 one's going to work as well. And you'll see right here, guys. Look. Come on, buddy. Come out. All right. So if I type in e, and I go 2 times ln 2, and then I just go minus 3 e times ln 2. Remember that e and ln are like inverses of each other? Plus 2. And check it out. You get 0. So both of them work. And then the 0 one definitely works. If you wanted to check that out, guys, look real quick. E to the 2 times 0, that's just 0. Minus 3 e to the 0, and then plus 2. And of course you're going to get, not insulting your intelligence, you're just going to get 0. So both of them work, both of them are solutions, and there it is. Alright guys, I hope you enjoyed this notes, and hope that you feel that you're stronger, guys. Better, faster, stronger. If you enjoyed this video, give me a thumbs up. I'd really appreciate it. I guess if you didn't like it, you can put a thumbs down as well. And I hope you got something from it. Alright guys, talk to you guys later. Bye.